Hello everyone! In this video, we are going to solve a classic dynamic programming question, maximum product subarray. So we are given an integer array nums, and we need to find a subarray that has the largest product and return this product. For example, in this array, the maximum product subarray is going to be 6, which comes from multiplying 2 by 3. Let's start with a brute force idea. We could pick every element, build all possible subarrays starting from it, and find their products. For example, in this case, we are going to have subarrays 2, 2, 3, 2, 3 minus 2, 2, 3 minus 2, 4, and then we will start from element 3 and so on. This approach is going to require us to use two nested loops, so the time complexity is going to be big O of n squared. Can we do better? And the answer is yes, with dynamic programming. Let's think about different cases. If all numbers are positive, like in this case, then the maximum product is just going to be the product of the whole array. But if the array includes negatives, things get trickier. Take this array. Multiplying all is going to give us negative 24, but the greatest product is going to come from multiplying 3 times 4, which is 12. This shows we can just multiply everything. Here is the key idea. A negative number can turn the smallest product into the largest if it's multiplied by another negative number. So at each step, we should track both the current maximum product and the current minimum product. Let's walk through an example. We'll initialize max and min with negative 2. Then we'll hit 3, and to update current max, we are going to take max of current number and current number multiplied by current max. As we can see, max of these two values is going to be 3, so we will update current max with 3. We are going to do the same to update current min, so it will become min of 3 and minus 2 times 3, which is going to be negative 6. Now let's do the same for the last number 4. Max of 4 and 3 times 4 is going to be 12. And min of 4 and 4 times negative 6 is going to be minus 24. As you can see, we found the correct maximum product. Now let's add another negative value to our array, for example negative 5. And as you remember, when we get negative value in array, we need to switch current max and current min. So current max will become negative 24 and current min will be 12. Now we will do same calculations as we did before, and current max will become 120 and current min will be minus 60. And once again, current max is our correct maximum product. Finally, what about zeros? And the great news is that we don't need to change anything, because when we will reach 0, our current max and min will set to 0, and on the next iteration they will automatically set to the next value, so no changes are needed. As to time complexity, because we only scan the array once, the time complexity for this algorithm is going to be big O of n, and as we don't use any extra memory besides some constants, our memory complexity is going to be big O of 1. Now let's code it up. I'm going to initialize current maximum, current minimum, and result to the first element of the array, and iterate through the rest. Now if num is less than 0, we'll swap current maximum and current minimum. Like so. and update current maximum, which is going to be maximum of num and current maximum times num. And we'll do the same for current minimum, but with min instead. And update result to the maximum of result and current maximum. And I didn't really mention, but we'll need res for cases like this, where current maximum will first become 6 after multiplying 2 by 3, but after passing through -2, it is going to become 4. So we'll need res to keep track of the best maximum product we've seen so far. And now we can return res. And that's it. We've solved maximum product subarray. I hope this explanation was helpful, and thanks for watching.